Hey everyone, welcome to this explainer. Today I'm putting on my senior architect hat, and I want to mentor you through what is honestly one of the most underestimated areas in Active Directory. We're talking about sites, replication, and trusts. Look, if you're gearing up for your certification exams, or maybe you're stepping into a new hybrid administration role, mastering these specific topics, it's absolutely non-negotiable. Getting this wrong can, and literally will, break an enterprise network. But getting it right? Well, that makes you the absolute hero of the IT department.
Okay, let's dive into this, because this right here is the core mystery of multi-site topology. I mean, you already know how to deploy a domain controller, right? But what happens when an admin updates users' permissions over in the London office, and that exact same user immediately tries to log in from Sydney? How does that data actually travel? How do you control it? And most importantly, what happens when the path between them just breaks?
So here is our survival manual for today. We're going to cover sites and network topology, unpack those multi-master replication rules, master our AD trust types, apply it all to a corporate acquisition case study, and then wrap up with the architect's cheat sheet. Let's get to it.
Section 1. Sites and Network Topology. We're moving from the logical down to the physical.
So right out of the box, Active Directory is completely blind to your physical network. Without sites configured, it just assumes every single domain controller is sitting in the exact same room. Think of an AD site like a local city neighborhood, Everything is super fast and highly connected. Inside that single site, what we call intra-site replication changes trigger automatically within 15 seconds. It's lightning fast. But what if you have a remote branch? Well, think of site links as the scheduled freight trains running between those cities. This inter-site replication is compressed and it's scheduled over those slower WAN links. Which brings us to your first exam practice question. Does intra-site replication use compression? The answer is A, no, because it assumes you're on a high-speed LAN.
Now, when you link these sites together, a really crucial behind-the-scenes hero steps up, the ISTG, or Inter-Site Topology Generator. The ISTG is just a process running on one single DC per site, and its entire job is to automatically build those replication connection objects between your sites. You actually rarely have to draw these lines yourself. So, practice question number 2. Which component automatically builds connection objects between sites? Answer, the ISTG. Knowing that this little guy exists is totally critical for your troubleshooting toolkit when those replication paths inevitably fail.
Section 2. Multi-master replication rules. Let's see how AD handles the chaos.
Unlike a traditional database that just has one master, Active Directory is multi-master. That means any domain controller can accept a write operation. So, exam check, practice question 3. Imagine admin A in London and admin B in Sydney change John Smith's phone number at the exact same second. Who wins? Well, Active Directory actually resolves this collision completely silently using 3 tiebreakers. First, the highest update sequence number, or USN, then the latest timestamp, and finally, if it's still a tie, the highest mathematically generated GUID.
Let's move to and see how this builds into the actual replication process. When DC01 makes a change, it simply ticks its USN counter up by 1. Then it notifies its partners, hey, I have an update. Step 3 is the absolute crucial point here. The partners pull the changes. Replication in AD is a pull-based process, not push. The partners actively reach out and ask DC01, hey, give me any changes with a USN higher than what I already have.
Okay, I need to put my mentor hat firmly on for a second here and warn you about a massive exam red flag. This is a very real resume-generating event, the USN rollback. If you ever restore a domain controller by just blindly rolling back a virtual machine snapshot without using proper AD-aware procedures, that USN counter goes backward. Other DCs see a lower number, they assume they already have that data, and they permanently stop replicating with that rolled back DC. The only fix? A complete demotion and rebuild of that server. Just don't do it.
The other major replication killer out there is lingering objects. Say a DC is isolated from the network. Maybe it was accidentally powered off in a closet somewhere for longer than the default 180-day tombstone lifetime. It completely misses all the deletion notices happening across the rest of the network. So when you finally plug it back in, it reintroduces objects that were deleted months ago. It's like a zombie bringing dead accounts back to life. These lingering objects cause severe authentication anomalies, and you have to manually hunt them down and clean them up.
Section 3. Mastering AD Trust Types. Let's talk about sharing identity.
Whenever 2 completely separate organizations need to share identity, you're going to need a trust, and you will be tested on these 4 distinctions: Automatic transitive trusts, those just exist within the same forest automatically. External trusts connect separate forests, but they use older NTLM authentication and they aren't transitive. Forest trusts, though, those are the gold standard. Whole forest to whole forest, transitive using secure Kerberos. Finally, shortcut trusts bridge deep leaf domains to reduce authentication hops. So practice question 4. Which trust type would you use to connect two separate forests with transitive Kerberos routing? Answer: a forest trust.
Now here is the golden rule of trusts that trips absolutely everyone up. Who trusts who? Always remember this. The resource domain must trust the user domain. The trust arrow always points toward the trusted users. You authenticate from the trusted side to access files over on the trusting side. Seriously, burn that into your memory right now.
Section 4. Case Study. Let's navigate a real-world corporate acquisition.
Here is the scenario. A UK insurance company, let's call them Contoso, acquires a financial firm in Ireland. The business leaders dictate that they want to keep both forests separate for 18 months. But, and there's always a but, the Ireland staff need immediate access to the UK's internal SharePoint servers. So based on our golden rule, what do we need? We need a one-way forest trust, where Contoso, they hold the resource, is the trusting domain, and Ireland, where the users are, is the trusted domain.
Now I want to share some architect-level tips here, because 3 exact problems broke this implementation in the wild. First, the trust creation failed immediately because the forests couldn't even find each other. The fix: setting up DNS conditional forwarders. Second, some of those Ireland users had old SID histories that were just getting blocked by default security. The fix there was applying selective authentication rather than turning off SID filtering entirely. Third, logging in was agonizingly slow because the authentication referral chain was crossing the WAN 3 times. We fixed that by deploying a read-only domain controller, an RODC, in a newly created Dublin site, so authentication stayed local. Practice question 5. If a cross-forest trust immediately fails to verify, what is the most likely culprit? Answer: missing DNS conditional forwarders.
Now, what's really interesting about this slide is that standard replication doesn't usually require certificates at all. But there are 2 rare critical scenarios where they absolutely matter. First, if you're in a legacy environment using SMTP for Intra-site replication, an expired enterprise CA certificate will stop replication dead in its tracks. You're going to want to look out for event ID 1311. Second, if users are logging in across a forest trust using smart cards, you actually have to export the root CA from the user's forest and manually import it into the resource forest's trusted root store.
Section 5. The Architect's Cheat Sheet. Let's talk daily operations.
All right, this is your daily survival guide and command line reference. Honestly, take a screenshot of this right now. The exams are going to test you on these tools, and your team is going to rely on them. Every single morning, your first cup of coffee should be paired with running repadmin/rep summary to check your health dashboard. Weekly, you want to run DC-diag with the replication and verbose flags to catch any topology errors before they turn into full-blown outages. And for new environments, use NL-test to instantly verify all configured trusts and make sure their statuses are healthy.
When you run those tools, you're inevitably going to see some error codes. Knowing how to categorize and fix them, that is crucial exam knowledge. If you see error 8614, your DC has been isolated way too long. You need to suspect lingering objects immediately and investigate with repadmin. If you see error 1753, the RPC endpoint mapper is unreachable. That almost always means a firewall rule is blocking your traffic. And if you get intermittent authentication failures across a trust, your secure channel might just be stale. You can repair it by using the netdom-trust/reset command.
So I'm going to leave you with this provocative challenge. If your network went down right now, today, would you know exactly where to look? Don't wait for an emergency to find out. Apply these daily checks tomorrow morning. Drop down in the comments and let me know, what is the worst replication outage or trust failure you've ever had to troubleshoot? Thank you so much for joining me for this explainer, and keep building those highly resilient networks.